Hi everyone, welcome back. Today we're going to do partial fraction decomposition practice. If you haven't yet seen my last video, please check it out. I walk over how to do partial fraction decomposition problems as well as a few examples. This is just some more practice if you need it. So let's start with this problem. We have integral of x plus 3 over x minus 1 squared dx. In this example, the denominator contains a repeated linear factor because x minus 1 appears with a power of 2. So we need one fraction for every power of that factor. So again, we can rewrite, I know that was a lot of words, we can take this fraction and we can rewrite it as a over x minus 1 plus b over x minus 1 squared. And I'm getting this from the table of my last video. So that is this problem right here. So again, please check out my last video. This is the table that I go over that will help you a lot in your practice. So, okay, now once we have these two simplified fractions, we can go ahead and solve for a and b. So I'm going to multiply both sides by x minus 1 squared. And this leaves me with x plus 3 is equal to a times x minus 1, because one of this leaves, plus b. All right, now I want to rearrange this so that it's in the same, so that the right side is the same form as the left side. So to do this, I get x plus 3 is equal to ax minus a plus b, and then x plus 3 is equal to ax minus, I'm going to say plus b minus a, just to keep everything positive. And now I relate both my right side, so I have 1x is going to be compared to ax, and then I have my 3 is related to my b minus a. Now, if this left side had something like a, x squared, then I would need to see if there's a term that also had an x squared, and then I would relate these two terms together. But because that's not in this problem, I'm not going to think about it too much, but just so that you're aware in future problems. So that did not work. Just so that you're aware in future problems, that's how you would do it. So from this, we can see that a is equal to 1, and then we get b minus a is equal to 3. We know a is 1, so this is b minus 1 is equal to 3. We get b is equal to 4. Sweet. Now that we have solved for a and b, we're going to put these back into our decomposition form. So we get integral of x, what is it? A is 3. A is 1, sorry. Integral of 1 over x minus 1 plus 4 over x minus 1 squared dx. Now I'm going to split this up into two fractions to make it easier. So I get integral of 1 over x minus 1 dx plus 4, just moving the 4 out in front, integral 1 over x minus 1 squared dx. So solving just this first integral right here, we get this is, what is this? ln x minus 1. I'm going to avoid the plus c for now. I'm going to get that later. And then solving this one right here is a bit more complicated, but I'm going to go ahead and use u sub for this. Now, if you're not aware with u sub, please check out my previous video. I made a whole video talking through how to do u substitution. So I'm going to rewrite this integral as for the integral of x minus 1 to the power of negative 2 dx. Then I'm going to say my u is equal to x minus 1, which means, my du, that was a little flash forward to the next problem. My du is going to be equal to 1 dx, so just dx. So now I'm going to rewrite all of this. So I get 4 integral u to negative 2 du. And using power rule, we can get that this is 4 times u minus 1 over minus 1 is equal to negative 4 u minus 1. Now substitute our u back in. We get negative 4 over x minus 1 is this. So now I'm going to combine these two integrals that we have just solved for into one. So this means that we get our integral of x plus 3 over x minus 1 squared dx is equal to, this is the original form, this is equal to ln of x minus 1 minus 4, oh, I missed this, what is this, x minus, this is supposed to be a 1 here, 4 over x minus 1 plus c. So this is our final answer right here. So again, notice how we went from a very complicated integrand to two simple ones that we can use normal integration techniques that we're comfortable with, and then just add them together using the linear property. And don't forget your plus c. All right, let's do one more example. We have the integral of 2x plus 5 over x plus 1 times x squared plus 4. So the denominator contains two different factors. We can immediately see first factor is x plus 1, which is linear, and the second one is a irreducible quadratic, because we cannot factor any numbers out. So we can rewrite this as 2x plus 5 over x plus 1 times x squared plus 4 is just simplified to a over x plus 1. So this is the linear. And then because this is a irreducible quadratic, if we go back to the table from before in my previous video, irreducible quadratic has this form right here. So we get a over x plus 1 plus bx plus c over x squared plus 4. So that's where we stand. And those are our two simplified fractions. Now that we have it in this form, all we got to do is solve for our unknowns. So in this case, our a, b, and c. So I'm going to multiply both sides by x plus 1 times x squared plus 4. So this will leave me 2x plus 5 is equal to a times x squared plus 4 plus bx plus c times x plus 1. Now I'm just going to simplify this equation just a little bit. So we get 2x plus 5 is equal to a times x squared plus 4 plus, if I factor all this out, this is going to be bx squared plus bx plus cx plus c. I can simplify this even further to be ax squared plus 4a plus bx squared plus bx plus cx plus c. Now I want to get it in the form of here, so I want numbers times x, and then I want numbers or letters times a non-x value. So again, to get that in the form, we get 2x plus 5 is equal to, grouping like terms, I get a plus b x squared. So notice how we have x squared on this side, so we have x squared, x squared. I'm actually going to delete these two highlights. Then we have an x and an x, and then we have a a variable without an x. So we want to get that in that form. Notice how on the left side there is no x squared term. That just means that this is a 0 right here. So that is equivalent to what that means. So again, we get a plus b times x squared plus b plus c times x plus 4a plus c. So again, and this is 0x squared. So now that we have it all the same, we have, we have our x squared value needs to be equal to 0. We have our x value, b plus c, needs to be equal to 2. And then we have our non-x values need to be equal to 5. So rewriting this, we get a plus b is equal to 0. We have b plus c is equal to 2. And then we have 4a plus c is equal to 5. I'm going to let you solve these on your own, with whatever method you choose. But essentially, once you solve it, you get a is equal to negative b, and that is equal to 3/5, and b is equal to negative 3/5. And then our c value is equal to 13 over 5. So once we have these numbers, I'm going to plug them back in to our decomposition form, and then we're going to go ahead and take the integral. So our new integral becomes 3 over 5 over x plus 1 plus negative 3/5 x plus 13/5 over x squared plus 4 dx. Now, again, this may seem still slightly complicated, but we can continue working with this as needed. So we can now, what can we do? We can split this into 3 integrals. So what that will look like is we have integral 3/5 over x plus 1 plus, because we can simplify this term down, I'm going to say this is minus, not a plus, because it's a negative, minus the integral of 3/5 x over x squared plus 4 dx, and this is a dx, and then we got plus 13 over 5 over x squared plus 4 dx. So we were able to use our simplified partial fraction decomposition and simplify it even further. So I'm going to take all the constants out. So we have 3/5 integral 1 over x plus 1 dx. That should be a very easy integral for you. Minus 3/5 x over x squared plus 4 dx. That one we can also do using u substitution, plus 13 over 5 times the integral of 1 over x squared plus 4 dx. So now these have become three integrals that we are very comfortable solving. So our first integral just becomes 3/5 ln of x plus 1. So that's our first one right there. Our second integral, we're going to have to use u substitution. I'm going to let you try the u substitution on your own. I'm going to go ahead and give you the answer that this leads to, but please feel free to solve it and check your work. So this gets us to negative, oops, I'm going to write it in black, negative 3/10 times ln x squared plus 4. So that's our second integral. And then our third integral is just similar to the arctangent formula. If you're not well aware of this, please check out your logarithmic integrals. So this is just arctangent formula. So this turns out to be, writing this in black, we get 13 over 10 tangent inverse times x over 2. So that's integral 3. And now finally all we do is we combine these into one using the linear formula. So we get, this is all equal to 3/5 ln x plus 1 minus 3/10 ln x squared plus 4 plus 13/10 inverse tan x over 2 plus c. And that is our final answer. So I know that was a lot of steps, but hopefully every step was a simplified version. So it may be tedious, but it's something you are able to do. So again, whenever you see a complex form like this, don't fret. You can simplify it into smaller versions to get a final answer. Hope that helps, and I'll see you next time.